a little introduction. I put in 3 talks for LCA, 2 serious, 1 not serious. So this is slightly technical, but totally not serious. I did this as a project just because I wanted to play with stuff, not because I had any real end goal in mind. And every good project needs a name. So I came up with the Programmable Ant Input Network, Community Alternative Velo Environment, P.A.I.N. And many of you probably know, but P.A.I.N is what cyclists and triathlons call their indoor training facilities, which is usually nowadays a trainer, a bicycle, and a TV running some kind of simulation or just watching movies. And just to give you a little idea of why I think I'm kind of out of my element on this. In my day-to-day job, my normal thing, I like to play around and analyze my bike rides. And I'm an amateur, not very good, but have fun athlete. And today, I'm making a bike data toy. Okay, that's kind of fun. Day-to-day job, I work on cloud servers. Today, I'm working with the Raspberry Pi. And normally, I play with TCP/IP. Today, I'm playing with Ant+, a little tiny protocol. And normally, I work on C language projects with 700,000 to 1 million plus lines of code. And this is 700 lines of Python. So don't criticize my Python. I'm not really very good at it. So indoor training took off with the advent of this program called Zwift. And Zwift is an indoor virtual reality training system that runs on Apple and Windows. And everybody has their own little avatar, and their bicycle basically goes at the speed of the power they're putting out. And what made it take off, there was many indoor training applications before. What really made it take off was the social aspect. And my process on this was, I started out with, I like to cycle. I think Zwift is cool. I came up with an idea, I can make some money and start a Kickstarter campaign. And I'm like, that's hard. And that's really not going to work out very well. So let's skip that. Let's make it open source. Maybe I can make a talk at LCA on this. And they said, oh, these cool LED lights that Grant told me about. You can control them. And maybe I can do something with that, with a Raspberry Pi. So with that, I came up with the idea for the P.A.I.N. And I'll show you the demo number 1, the simplest version of this, if I can. Here's where where am I on this stupid thing? Okay. Okay, that's. Okay. So the simple version of the P.A.I.N. that was done here is a shortened version of the thing I built at home. And if this works, it's going to pick up. There we go. It picks up my power and controls the color of the LED lights. And in this display, the way it's doing is it's doing a scrolling graph across. So if I go and do hard, it goes red. And if I go easy, it can go back to blue. And white is just, and then if I stop completely, it'll go to black and stop. So that's the simple version of it. And then go back to here. Why did I do this? How does this fit in? Well, I looked at all the cycling applications out there. And the big one, the first ones that we were talking about earlier are Garmin and Strava. They're basically applications to collect data from what you're doing and let you analyze it. And then there's a bunch of Trainer Road, Sufferfest, a whole bunch of coaching applications, which are all about, okay, you can use your data. I can give you workouts. You can get stronger and faster. And then there's all these virtual reality apps. I counted about 18 last I checked. And I really didn't want to try to do one of these. That would have been big and hard. So I said, oh, and the other one I mentioned earlier was Golden Cheetah, which I want to give a shout out to. It's open source. It's a data analysis. They put in some virtual racing stuff. And I said, I want something that's just on the entertainment side, just fun, because I'm going to use it for me. I'm going to put it in my pain cave, and I want it to just be entertainment while I'm killing myself on the bike. And I want something I can play with. It's not going to impact anything. It's not going to break other things. It's not going to go anywhere. So the way I set this up was, when I got the Pi, I looked and said, oh, turns out there are nice little Python libraries that you can collect the data with the Garmin with USB dongle, run it into your Pi, and then take that data. You also can use the GPIO pins to control the LED lights. So you have your inputs, your outputs for a simple base case. And for the inputs, what we use is power sensors on the bike. And this used to be really expensive. It used to be that the only bike power sensor was SRM crank sensors. They cost $5,000. You'd see the pro teams and maybe really high-end cycling studios would have. And it's gotten down now where for $500 you can get a bike sensor, which at least brings it down to a more reasonable level. And you can sense power in many places on the bike. The ones I have here are Garmin pedals. You can do it in the cranks. You can do it in the bottom bracket. There are wheels that do it. There was even one vendor for a while that was using the chain vibration. And if $500 is too much and you really want to go even farther, you can just take a speed sensor and a trainer that has a known power curve and get power data out of that. That's called virtual power. And there's actually another project that somebody did called V-Power that was take a Raspberry Pi, take the speed sensor, and make power output. So now you've got the data coming in. And the data that comes in using what's called Ant Plus. And Ant Plus, from best I can determine, was originally done by a Canadian company called Dynastream that then got bought out by Garmin. And I thought I would have to go all trivial and take USB byte streams and decode the USB byte streams. But it turns out they have a developer agreement with free sign up. You can find out the standards for all the major profiles, and so you don't really have to reverse engineering. And even have software kit with an Apache style license. And so I didn't actually use their software, but use the standards to figure out the data streams. So Ant is built on a layered standard, just like any other network standard. The lowest level standards is a 2.4 gigahertz, which is the open frequency that's used by Wi-Fi and other things. There's an Ant protocol, which is their activity protocol on top of that. And then what you do with the data is pretty much open. So Ant, one reason you see me here with this little USB extension cable here is Ant uses a channel in the same area that Wi-Fi does. And so if you've got Wi-Fi saturated in your house and you're trying to pick up the data in one place and your bike's over there, it doesn't work very well. So getting it close is pretty important. Ant, unlike other protocols we're used to, is a time division multiplexing protocol. So to save power and to work, they use broadcasts, and every different sensor goes at a different pace. And they sense the other sensors, and they choose a slot where there's no others. And then they use the fixed interval after that. For the power sensor I'm using, and when you program it, the standard profile says you get 4 messages a second maximum. And I thought out at first that, it's going to give me power output 4 times a second. No, the pedal only knows the power output of 1 cycle of my crank. So what it does is it's going to give me an update of the power every cycle. And this is IoT, right? You expect some level of security, or maybe not. The Ant standard has 120-bit AES encryption between that pedal and that dongle with a single symmetric key, which is an open secret that both ends have to know to be able to communicate. Authentication, the pedal and the sensor don't know about each other, and there's really no integrity there in the protocol. So, a nice IoT insecure protocol. The way the two communicate with each other, they set the network key with a shared secret. There's different channel types. In this case, it's a bidirectional transfer. And then the channel ID is basically which type of sensor the dongle is looking for. Now, there's heart rate sensors, cadence sensors, power sensors. In this case, I wanted B for the power sensor. And then, obviously, they have to agree on which channel. And then there's the period. They both have to agree on what the period is. And then you get so there's only one channel available on the dongle per sensor type, so I can't pick up two power meters. The discovery logic in the library that I'm using is very stupid. So it's just the first available. If you happen to have another power sensor here, I might have gotten the wrong one. The USB stick can handle 8 channels, so it can pick up a speed, a cadence, a heart rate, power sensor all at the same time. And it's a broadcast protocol. And what that means is if I turn my watch on to listen to that power sensor and the Raspberry Pi is listening to the power sensor, they'll both pick up the same data at the same time and they won't bother each other. Yes?
Why is it not primary?
Because I didn't implement it. Well, two things. One, there is a who's out there message that gets broadcast. The other one is you can implement calibration protocols. So you can, I'll get to it, but basically there's a get set protocol, and that's used, for example, I can use my another app that does do calibration to tell the pedal that 0 is at this torque value. So Ant has different protocols. There's bicycle power, speed and cadence, heart rate monitors. There's even a treadmill one. And then there's all these other ones for audio, muscle oxygen. So they went 9 yards. They're all in. And Ant has been around for a while. In fact, the earliest Python libraries for supporting it are like 10 years old almost. In the power profile, every profile defines a set of pages, which is basically what the first byte of the message is. And the page tells you how to decode the rest of the message. And they're grouped in terms of device-specific ones, like Garmin will have ones for their devices. There's a common set of ones. And then there's various manufacturer-specific ones. For what I cared about, there was the one I really want to use was the standard power one, because it's a simple one, gives me the power data. There was a bunch of other older ones that, it turns out this pedal also puts out the torque torque effectiveness message as well. But the ones that are like on a crank will give you torque at the crank. But there was a simple message, which I'll show you for just power. The calibration you can do is get set parameters. That's what, if you run the calibration app, it uses to set 0 on this one. Measurement is basically just like your camera has a raw data output, you can get a raw measurement output stream. Manufacturer information, basically the pedal will say, I'm a Garmin, and the product information is model number. That is used for when you implement discovery, or you want to say, well, is it the pedal I'm picking up, or the trainer, or the wheel sensor? Battery voltage, it's kind of obvious. Inside the pedal is a bunch of little batteries. You want to kind of know what's left in the batteries. So the only one I ended up implementing in the first version is the power page. The power page sends you a message that looks like this. The power only message has an event count, which I'll explain in a second. There's a power balance, which is if you have a sensor that has left and right, the middle number 80 will be your balanced, 0 will be on one side, and FF is a defined value for this sensor doesn't give you balance information. The cadence is 1 byte. I don't know if you know, but byte cadence, like, you're doing well when you can do 130, 140. The pro track sprinters can spin 180. No superhuman, except if you hook a motor up, is going to do over 1 byte. And then they give you 2 power values. They give you an instantaneous power and an accumulated power. The accumulated power is to handle dropouts. So this is a broadcast protocol. There's no guarantee that you're going to hear every packet. So every packet has an event count that wraps, and it has a power count that wraps. And so if you missed 1 packet between 2, you could get a more accumulated power. Where this ends up in the Raspberry Pi after it goes all through the Python libraries is there's a class that gets callback with the data of the packet, and it looks for, is this the power, standard power data, takes the count, if there's no previous data, it records the power value. If there is previous data, it computes the power based on the event, the number of events, and it has to deal with the 16 byte and the 8-bit wraparound. So you got power. What does that mean? Well, in cycling power, there's something that's called functional threshold power, or critical power. And I'm not going to dive into the biomechanics and all that stuff because it kind of go off in the weeds very deep. But in this case, this is a graph of my data when I was doing a virtual cycling race on Zwift. And the left graph is how much power I was putting out, and the x-axis is over 1 interval of time. So you'll see I was able to sprint for 500 watts for 10 seconds or so. And over the whole race, my average power was way out there at 220. So what this turns out to be very common. So even a pro cyclist is going to have the same graph, just bumped up a whole lot. And my wife has the same graph, only bumped down. So they came up, what matters for training and so on is what's called functional threshold power, which is defined as what you could hold for an hour if you were really, really motivated and really, really intense. Because that's basically the level you could hold if you were staying completely aerobic. If you went anaerobic, you're not going to be able to hold it. Normally, most people can't test that for 60 minutes. So usually what you do is you test for 20 minutes and you take 95% of that, because that kind of matches. There are even simpler and better ways to test it, but so now you've got this functional threshold power. What do you do with it? So the standard training with power methodology now is to have different zones, and you have your workout go in different zones over time. So as you see in this graph, the yellow zone is 100% of your threshold power. And you see this oval over here, and in zone 3, and the edge of zone 4, that's what's called sweet spot training. And that's the area that most people use for aerobic training. So if you want to improve your FTP, you want to get more aerobic power, you want to stay in that zone. If you want to be able to survive in a really hard sprint, whatever, you have to be doing level 5, level 6. So I took this, and I used these zones to do the colors on the LED. So what happens is the LED code works by saying, okay, I want to insert a value of power into this strip, and then sets pixel X and shifts them all over, and computes the zone based on the power. Now, that was the first demo. I'll do another one after this. The other thing is this wasn't horribly expensive, because obviously Raspberry Pi, I bought commercial one to get this thing started, went whole hog and spent $140 for this thing. But there's no reason you couldn't do this a whole lot cheaper. You've got a Raspberry Pi, which is equivalent to this one in the conference. So you got that, buy a case, get your SD card. The power supply, for this demo, I'm just using a little USB supply because I can actually run that many LEDs without burning out. The one at home, bigger, longer strip, has a more substantial supply. There's no reason that the same thing can't be done with Bluetooth low power. So given that, you can drop the most expensive part of this, which is that Ant sensor. Let me try to see if I can get the second demo running. The first one's still running, hallelujah. So the second one, the two things I did was, first of all, to make this more automated, I wanted to have some sort of startup-like sequence because SSHing into my Raspberry Pi every time I want to use it is not so useful. So I have it set up to run on boot. And then the other one was on my particular display, seeing the color strips hanging down wasn't particularly useful. So I went with something where the color is now based on my power, and how fast it goes across is based on the cadence. So if I go into really low gear and go really fast, it steps faster. And if you go super big gear and really slow, it steps across faster. And it doesn't look as well on this display, but it looks much better hanging down because you kind of see it in the room and get an ambient effect. Let's go back to this. Where's my mouse? Here, mousey. I know. It's like, there it is. So now I've got this thing going. Where am I going to go from here? Well, the first one I wanted to do was go more entertaining. So there's no reason you can't take a Pi with a little touchscreen on top and do something, make a better user interface, make it have strip charts or whatever. You can use this to control light bulbs. So the LED light bulb that's sitting in that room, do whatever I want with that. And I've got a bunch of other art project ideas, like taking LED light strips, putting them around a bike wheel on the wall, having it virtually spin based on what's going on. And to be honest, I just want this to be a platform where people can be creative and come up with also, just like Mark with his crazy lights. The initial version of this just used whatever power sensor is as close as possible with Ant. That's probably not what people really want. You want to be able to say, I want this sensor, and then have it always come back to the same sensor. The other one is the Bluetooth low power most of the newer sensors all support Ant and Bluetooth low power. Bluetooth low power means you don't need to have the dongle. It also is more reliable than Ant because it uses a different frequency. And virtual power would be another great thing to support. And the other one is that for usability, setting the FTP in an INI file in the thing before I start it, probably not what I want. So I want to have a real interface that's there so that anybody can just update, control it. This, I said to myself, now you've got this thing running in the wall doing data collection. What could you do with it? Well, a lot of times when I go and ride on Zwift or do a workout, these things end up capturing into portals which then you have to go log into their website to download the data that you just created. There's no reason that this thing couldn't be a passive entity and upload it to Dropbox, OneDrive, whatever NFS server, whatever you want that's there, and you can just go in with Golden Sheet and analyze your data. It could just be a passive thing, always handling it. And lastly, computing FTP. If you've ever used the watches or many of the other things, they automatically compute FTP based on your past results. And especially for this thing, we're not using it as a training device, so it doesn't matter that the FTP is super accurate. In other words, if my FTP is a little wrong and it comes out green instead of yellow, okay, it looks wrong, but it's not like it's going to have an impact on what I've done. So taking this forward, I want this to be a community project. Having Steve's toy is fun, but I really want this to be a teaser for what people could do with it. And I want to create opportunities, and I want people to really be creative and pull all sorts of new things in. I'm not going to build something that's going to be an open source Zwift. Maybe somebody's going to figure out how to marry this with Tux Kart Racer and do something fun. But it's really not worth it to try to directly compete with the big guys. They have all the business money and everything else. But this is an opportunity to be creative and use the technology in a different way. It's also a good way to make something that is not super nerdy, because it's way too often in the fitness world that everything is so nerdy that nobody really wants. So my wife doesn't really want to get involved with it. And I just wanted to have something fun. I mean, part of the reason for doing all this is, okay, I could go ride the bike again and I could do something different, and I'm kind of teasing myself. I'm hiding the fact that I'm doing a workout. So everything about this wasn't easy. First of all the Python ant libraries, everybody was really active 5 years ago. They're basically abandoned. So if you actually looked at the screen in the first demo, it's putting out all these noisy messages saying, I got a USB timeout, I couldn't do this, I couldn't do that. And I said, well, what? Oh, that's a print, it's buried in the library. Oh. And the threading model of, the threading model of the different libraries was completely different and broken for like the second demo. They were like pulling on one thread, putting them in a queue, picking them on another. So the whole thing, so I'm kind of thinking that the time has come to basically roll a small version of it into this project as itself. I wanted to reuse, but at some point, if things are died, you have to kind of take them over. The config files there, we need to set up utility, it's got to be something. And lastly, if you look at the internals of Golden Cheetah, which is written in C++, the power meter handling there is several thousand lines of dealing with all the quirks of various power meter vendors. I don't really want to get into that because I don't have those, and I'm not going to build for things I don't have. If other people have things and come along and want to figure out how to work it out, that would be great. The code, I was just about to put it on GitHub, and then I said, this really needs to be at least cleaned up, and the documentation has to be enough that everybody isn't going to be hitting me with emails saying, how do I do this? So I put a deadline in for myself. The Linux source people wanted an article. The article is going to be about how you can build one, and that's when I'm going to put the source up, because it'll be cleaned up at that point. And with that, thank you. And people are free to come down if they want to play on the bike. Thank you.
You mentioned at the end power meter quirks. How have you found the pedals to be in terms of, I've only ever trained on crank-based power meters, so I don't know anything about the pedals.
The pedals, I actually mailed back, once I got them calibrated, which is calibration, all power meters work by sensing strain, and then use the strain gauge value to then compute that back to some power. And So the pedal ones work by having a 0 value. So what is the strain gauge value with no pressures on the pedals, and then they go forward. The trainer ones often work by, at temperature, they have to spin down. So that's one of the reasons I didn't want to get into calibration, being all different. But anyway, once I calibrated them, they worked fairly well. But the other thing is they're very aggressive about not sending data when you're stopped. So you may even notice the demo probably still keeps running just because that was the last data point it got.
So one of the great things about having our own data is that presumably we could construct uploadable files for Strava or
yeah, there's a very much a
else.
standard called the fit file format, and there are tools to produce that file, parse that file, merge files.
What other sensors could we use to get power and things off of a bike, or do you think just getting a good trainer is a good way to get that?
Depends on the price point, right? So nowadays, the trainers, the best ones are about $500 to $600, and then you can go on up. I saw the one at the Italian art show for $12,000. No, it was carved wood and gorgeous. But I think that from a hacker point of view, you can pick up a trainer almost at Goodwill, and then you can use a speed sensor, which you can get for $30, and you can get virtual power. That's why I want to make virtual power one of the options in this. So you can do that with just that. Especially since, like I said, you're not after accuracy. You're not in a racing league and you're trying to, I can go 230, you can go 220. It doesn't matter. It's just the color of the lights.
Less of a question, more of a statement, I guess. Many years ago, there used to be a kit for the PlayStation 2 called the Game Bike.
Okay.
And you basically put your bike on a trainer, and the steering wheel would, where you're pedaling, would had a little sensor, like a speed sensor. The pedaling would be the same equivalent to the race car control pads.
Okay.
So you could actually play games, race car games, and as you pedal faster, your car would go faster, and your steering. I was thinking you could actually quite easily re-implement something like this.
Right.
The same way, so you could actually enjoy, instead of just Strava, but
Yeah.
playing games. And
well, that's why I thought the Tux
quite-
cart was a natural, but then
Yeah.
I looked at it, it was like, but then how would you do the steering? And then
Yeah, that's what I was trying to work out as well.
there's a question way at the back. To make it user-friendly, you need to be able to have, since that thing can put a web server up really easy, you put a web server up with the simple kind of setup panels you see in any of these other gamified apps that basically will show you all the sensors available. You choose that one, and it's kind of all point and click, and it shows you what's right there. This is right there. Subsurface is moderately user-friendly.
Yeah, I have to say, that seems to be exciting.
That's why it's not in here. I've tried to get and I've got like connecting to the pedal, and that was it.
I have a dive with that's the same ad over out there. It's very complicated. It doesn't show just the images.
Okay.
I don't know, but I've got a solution for it.
So I'm wondering if maybe there's some way to.
Oh, I have several things. The pedals do both Ant Plus and BLE together.
More questions?
Matthew.
You said there was no security in the Ant Plus protocol. I know when I paired my heart rate monitor to my watch, there was some like 5-digit code or something.
That's actually the serial number of your watch. And it broadcasts it as one of the pages. And so the pairing is basically your watch saying, oh, I'll take that one. And that's kind of what this would do with a smarter, you'd have a scanning one on the web page and it would show you all the ones, and once you chose that one, it would just repeat trying to get the same one every time.
Me again.
Yes.
Have you tried sending to a trainer that's a ant trainer that's got the like the Bushidos and the tacks and stuff like that?
Yeah,
Have you actually tried
that's
doing
another profile page that's available in Ant that's basically defined in the.
that? So you haven't actually done it yourself?
I
you
haven't
just-
done it, no,
yeah,
but it's definitely there.
quite cool. 'cause
Then
it's
the
just
question is what do you want to control it with? It's actually not very difficult to control it. It's like, well, what data do you want to?
Yeah.
You know.
Smart trainers is what I was thinking of.
Well, I mean, you could do something as simple as like having a web page where you say I want to be going up a 10% grade, and you click, and it.
If that's the end of questions, I'll just ask you to show your appreciation to Stephen.